Hi everybody. This is the blue gene problem. It is section uh, section 11.7, and it is problem number 3. Problem 3. And you know, when I was a kid, we would have to buy the blue jeans, just completely dark blue, and very hard material, and you'd buy them about 2 sizes too big. Then you'd take your blue jeans home. I remember when I got my very first pair, I was about 15, and I was so excited, and I'd take them home and you just put them in the washing machine and you wash them to try to get some of the color and to get them softer out. It was kind of funny. Today you just go buy them. You could buy them all ripped up and everything. It's kind of silly. But anyway, here we go with the blue gene problem. I think to start this problem is a little tricky just because, first of all, to start with, they have 100% of the color. And what does that mean? Remember, 100% of the color means, well, percent means 100 out of 100, right? The percent sign means out of 100. So 100 out of 100 means 1. So the first term of this sequence is 1. Okay, now you lose 4% of the color. So you take what you originally have, 100%, and you subtract 4%, which is 4/100ths of the original 1, right? This is 1 minus, another way to write this is 1 minus 4% of 1. Okay, and then when we do that, we're going to get 96/100ths when we do that. All right, and so that means after the first washing, it'll have 96% of the color. Okay, now we do that again. We take 96% or 96/100ths, and we subtract 4% of that. 4% of 96/100ths. Okay, and then I think when we do that, let me see. When we do that, do I have that somewhere? Let's see. We'll take 96/100ths and we'll subtract 4% of 96/100ths. There we go. Yep, and we get about 92%, 0.9216. Okay, but let's just go with that's 92% approximately. It's close enough. It's approximately. All right, and then we're going to take that. Now I'm just going to keep that in here, and then I'm going to say the answer minus 0.04 times 0.9216. Okay, I'm going to do it again. And the third term I'm getting here, it looks like the third term is about 88% of the color will be left. Okay, and then we're going to take 0.88 and we're going to subtract 4% of 0.88. You know, we could just keep doing this. Now let me stop right here, I guess, because let me show you an easier way a little bit. You know, if you think about this right here, what's happening every time, like even with the 88, look, an easier way to do this is if we factor this 88/100ths out, look, it's really just going to be 1 minus 0.04, right? And so what we could really see here is we have 88/100ths times 96/100ths, and that's what's actually happening every time. See, if you factor a 96/100ths out of both of these terms right here, it'd be 96/100ths times 1 minus 0.04, right? So it's really going to be 96/100ths times right here, 96/100ths. So what I'm trying to show you here is that the common ratio is 96/100ths. Now, if that all is confusing, then the other way to come up with it, after you've come up with the first few terms, just no big deal. It's very easy to come up with the common ratio right here. Even after you just come up with the first term, once you have that first term, you know the common ratio. It's going to just be 96/100ths divided by 1. And so you can see that the common ratio is 96/100ths. All right, so really the easier way to do this now is just to multiply. See, if I take 1 times 96/100ths, I get 96%, right? Now I multiply that by 96/100ths again, and I get 0.9216, 92%. Then I'll just multiply that by 96/100ths, and I get 0.884736. So it's about 88%. Okay, now I'm going to just multiply that by 96/100ths, and I get about 85%. Just rounding, I'm rounding there, okay? What I really got is 0.849346656. Okay, so I'm just taking my previous answer every time and I'm multiplying it by 9600ths. Okay, and now I get about 82% is the next term. 82%. Okay, so how many is this? 1, 2, 3, 4, 5, 6. I think the problem said to find the first 10 terms, right? So 1, 2, 3, 4, 5, 6. All right, so let me see. This will be term number 7. I'm going to multiply now by 9600ths again. I get about 78%. Approximately right. It's 0.7827577897, but we're just going with this. And then it's about 75%. Okay. So look at how quickly it goes down to 75% of the color, and that's when I was a kid. This is what blue jeans did. You didn't have to wash them very many times, and they were quite lighter very quickly. How many washings is this? 1, 2, 3, 4, 5, 6, 7 washings, right? 7 washings already. All right, and so let's see. This is 1, 2, 3, 4, 5, 6, 7, 8 terms, and so let's see. 9, 10. Okay, let's do 2 more. 0.96, and we got 0.72. 0.72, and then times 0.96 again, and we get 0.69. 0.69. All right, so that's the first 10 terms or so, right? And we can see here that t sub 1 is equal to 1, and the common ratio is going to be 9600ths. All right, so therefore the formula, if you do it correctly and don't give the partial sum formula, but you actually use the term formula, not naming any names or anything of the person who might have made a mistake like that. Sigh. So t sub n is going to equal the first term times the common ratio of 0.96 times n minus 1, right? So they want to know, when are you going to have 25% of the color? Or in other words, when am I going to get to this term right here that is 0.25, right? Because that'll be 25% of the color will be left, of the original color will be left, right? Because that's what all these are. They're just percentages: 69%, 72%, 75%, etc. All right, so in other words, 0.25, when will that equal what n will make this work, right? N minus 1. And so you could see here it's going to be, can I do this all in one step? Well, hopefully this won't throw anybody off. Log of 2500ths, right? Divided by the log of 9600ths, because it's 1 times 9600, so that's all I have over there, is equal to, and remember the n minus 1 is going to go, it's going to go outside the argument when you take the log of both sides, and so this is just going to equal n minus 1 right here. I did a bunch of things in one step, so hopefully that's okay. All right, when I take the log, let me see. We'll take the log of 2500ths and divide that by, oops, I got to put a parenthesis there. Log of 2500ths and divide that by the log of 9600ths, and I get, yeah, about 33.9. Well, 33 point, really I get about 34. It's really close to 34. So right over here I get 34 equals n minus 1, and so n is going to equal, but I mean, it's really 33.9594, really, so I don't know. Should I keep it there? Because maybe I shouldn't round that off. But if I don't round it off, then I got to carry it out quite a ways. 33.959. We'll leave it right there. Okay. Let's do it that far out. 33.959. I mean, dot, 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 it keeps going, but that's, there we go. And then if we add 1 to both sides, we can see it's going to be 34.959. And really we just want to know how many washings to get to 25% of the color. Well, you could see, if I take, and we could even just figure this out, but T sub 34, let's work that out. It's going to be 1 times, and then we can see here 96 hundredths to the 33rd. And let's see how much color we'll get here, okay? It's going to be 96 raised to the 33rd. And that's about 26% of the color here. This is about 26%. Okay? And so let's look at T sub 35 and see if I think that's going to go over, or that's going to be too small. So I think we're going to want to go with 34 there. But I'm not sure, so let's see. It's going to be 96 hundredths raised to the 34th. It's going to be T sub 35. Yep, and that's going to be, well, it rounds to 25%, so I'm going to go with 35. I'm going with the 35th term. It rounds to 25% of the color left. I don't know what the answer is in the book, but they say about 34 times, so close enough. Oh, wait a minute. I answered everything but the 10th question, or the 3B. How much of the original color would be left after 10 washings? Let's see. Did I get to 10 here? I think I did. After 10 washings. Okay, wait a minute, because there's my first washing. First, second, third, fourth, fifth, 6th, 7th, 8th, 9th. Oh, wait. I got to go one more. I got to go one more there. Okay, so I got to take that 0.69 times 0.96. I got to just find the next term there, 0.66. The reason I got to go one more term is because so it looks like the 10th washing will really be the 11th term, because this is before you've washed it at all, your first term, right? So by the way, I just think I didn't answer that. So after 10 washings, there'll be about 66% of the color left. Okay. After 35 washings, there'll be about 25% of the color left. I mean, close. It's very, very close. 34% or 34 washings are very close. If you said 34, that's fine. All right. Hopefully that makes sense.